here you go. So this is the Moivre's theorem. This is where you're going to start using this stuff. So here's an example with the power of 4. Okay. So first of all, we're going to try and write this in polar form. Okay. So what is that in polar form? We have to go through our modulus and stuff. 3 squared, 4 squared is 5. So z to the power of 4 is 5 cis. Try and find the arc sine of 305. Do the same with the arc cosine of 405. And if someone's doing that, it would be great. I believe it's 59.
0.64 for sine.
No, 7 degrees. Wow, it was about 59.
So we're going to cross it out. 36.9. You guys happy with that?
Yeah.
Now I've done that on my calculator. I've saved that number on my calculator, but that's in polar form. Now what I'm going to do is I'm going to write it down like this. Now this is probably where you go, what is this all about? But this is just saying that z to the power of 4 is 5 cis 36.9 plus lots of values of this 360, isn't it? You know, if I went 36.9 plus 360, it's the same thing. If I went 36.9 minus 360, it would be the same number. If I did 360 times 2, that would be the same number. Okay? Is that happy with that? So now what I'm going to do is I'm going to apply the Moivre's theorem and go, okay, so z therefore is going to be 5 cis 36.9 plus 360k to the power of 4, which in other words, sorry, not 4, a quarter, which is 5 to the power of a quarter, cis 1/4 times 36.9 plus 360k. Now, we'll not stand up here and say that looks easy, but are you guys following me at least? Because what I'm going to do next is just sort of try and get rid of that quarter. Okay, so how am I going to get rid of that quarter times? I'm just going to go, this is the 4th root of 5, cis, what's a quarter of 36.9?
9.222.
Remember, I've got it stored on my calculator, so I'll just divide that by 4 and get 9.22. 9.22. What's a quarter of 360k? 90k. So there is my number. That's my number. So now what I'm going to do is substitute in, okay, let's go, k is 1. So 4 root 5 cis 9.22 plus 90, which in actual fact is the 4th root of cis 99.22. So there's one answer. You guys follow that? If I say, and I probably should have done to start with, when k is 0, what's 9.2? It's just 9.28, so that's just the 4th root of cis 9.22. So now what I'm trying to do is think, where are these two on an argand diagram? I've got one there, I've got one there, sorry, one there. Where are my other two going to be?
It's going to make a cool thing.
Yeah, there and there, right? So I could actually just go, I know what they are, because you're intelligent, and you know that this one here is going to be 9.22. So what's our, they're going to be?
70.87.
Yep, so some of you are giving me the right answer, some of you not. This one here is 9.22. So what's that one there? 90 minus.
80 point.
Again, we're still trying that. We're going in that old chestnut. Let's just go. Let's chuck in k is -1, and then go. Okay, so this is going to be the 4th root of 5 cis 9.22 minus 90. Does that make sense?
Yeah.
That's going to be negative. Negative.
Yeah, and then it'll be k because yeah, k equals 2. Because if it was -2, then it'll be they'll go over 180. That's not what you want. So just, okay.
Let's just try it. I don't know. Try it. So that's when k is -2. Remember, I'm going back into this k up here, eh? Just so you know, I'm going to back that k back up.
No.
So 4th root of 5. That's still our R modulus. This is now the value is 180 minus 9.22, which is
Negative.
170.78, but it's a negative number. So there are our 3 answers. Hopefully, that's done without a calculator. Does that seem right?
Yep.
See, there are 4 answers. Why are there 4 answers? Because it's z to the power of 4, exactly. Because there are 4 roots, and we've done that with you guys. And if you don't remember that, you've probably hopefully clicking on it now. And obviously, some of these answers are in imaginary plane. Most of them will be in the complex number realm, and there will be some real numbers thrown in. But what did you notice with the 2 examples we did? Z to the power of 4 gave you every 90 degrees. We did one down here, which was the cube root. Every one was 120. Why is that? Because it's each complex number is the same plus 360, and if you're thirding it, then it's just an extra 120 on each time. Okay. So if you understand that, it's a pretty good thing